All right. Welcome everyone to another Amplifying FSharp episode. I'm your host, Jimmy Bird. Today I'm also joined by David and Florian. They're mostly going to be hanging out, but let's kind of get started here. Let me go ahead and share my screen. Today we're going to be talking on the subject of generating the language server protocol spec in FSharp. This is going to be covering kind of a little bit high level of like the LSP and some of the stuff around being able to take some of the projects that we've previously looked at, which is like Fabulous AST and generating on that. But before we get into this topic, I'll do a little bit of housekeeping. We did go on a longer break this time, but we are back. We're going to be finishing out the rest of this year. I'm going to be taking most of September, and we have other Amplifying F# team members taking other months and subsequent, and you'll see what they'll be cooking up here soon. Additionally, thank you to everyone who donates. We do have a donate button here, so you can come to the donating on our Open Collective. We are going to be doing some more work with this soon. We're going to be spending the money on getting some Ionide getting started features a little bit better, specific around error messages or how you get your SDKs or if your restores are a problem. And so look for that in the few coming months. Um, Anyone else have anything else they'd like to start before I get into the meat of the topic? All right. Well, so let's start with the kind of just the preface for what this is. So if you're not familiar with the language server protocol, this is the specification that Microsoft has provided around having the ability for a backend language server to do a bunch of work, and you can bring your own editor. So many editors support this. VS Code is specifically the one we're dealing with today, but a lot of people can bring like Vim or Emacs or any type of other editor. Even I've seen people use Sublime Text with FS Autocomplete. And so, but the specification has a lot to it. If we actually go look at the specification itself, this scroll bar is pretty big. And as you can see here, that this is a lot of like interfaces and kind of like types around this stuff. And this all kind of regards around all this stuff kind of result or resides around like TypeScript. And so this is very TypeScript-y interfaces. In the past, we had to basically just look at this document and copy and paste from it and make manual tweaks when we thought something was out of date. Luckily, uh, last version, they've introduced something called the meta model. And so this meta model is just a JSON file that describes all the stuff that's in this document. It won't look good on here. Let me just actually go to my editor real quick. And we'll look at I have the meta model pull up right here. And so this meta model defines a few different kind of various things that exist with this specification. We have something as requests, which are basically the back and forth between the client and the server. Notifications, usually just a client or server will notify the other thing about something else. Structures, these are generally just like the normal types that you would think of. So this would be something like your text document editing or looking for find all references, these kinds of things. Enumerations are small pieces of information around like what things exist. They're typical in enums that you think of. In this case, like here, we have like semantic token types. This could be like namespace or type or class or interface. So these are the things in your editor when you see these different um, structs here. You can see like these have potentially different keys to what these are. And then
Yep.
similarly, type aliases are
Jimmy,
just,
could
yep,
could you bump your font once
aha,
or
yes.
twice?
That
So
is always the thing to forget to do.
yeah, no worries.
So the type aliases are kind of the same thing that we use in FSharp for type aliases. These are things that don't really have their own necessary type, but they are a idea of a certain shape of things. And so, for instance, here would be like a definition could just be a location or a array of locations. And so, this is like if you go to definition, you could actually have something defined in multiple places. This might be useful for things like overloads or something like that. And so now that we have this meta model, this allows us to actually generate these types from this. And so a little while ago, I did the work on generating all these types, at least for the structures, the enumerations, and the type aliases. Let's see if I can, I didn't have this pulled up, but if we go to the issue for this, there is a pull request that I did quite a while ago, generate types from meta model. You can come to this pull request and you can check it out. I'm going to cover just the high level bits of this today, but I'm not going to go super deep into all the things here. The important parts that is I was able to basically read that meta model. I'm able to parse out all the things from that meta model, include structures, type aliases, so on and so forth. And this generates all the types. And so, for instance, when we go back to here for the language server protocol project, so one thing I guess I should mention here is we have a separate project for the language server protocol. So in the terms of like FS autocomplete, we have this idea of different projects represent very specific things about what they do. And so language server protocol is just about the spec. It's not, doesn't have anything. So like FS autocomplete has a lot of the knowing how to deal with F#. This is just purely the spec and some lower level handling, so it knows how to kind of communicate with the client and the server. That's about it. And so I was able to generate the types here. And one of the things that we could actually look at is that types generated file. So you'll see that it's labeled types.cg.fs. The common kind of idea around code generated files is you also put CG or G in their file name, so you kind of know that they're files. And so in here, this is a rather big file as well, but it has a bunch of generated types in here. And so if we actually take a look at something in the specification, let's go to something that's kind of like that we'd be doing a lot, which is like text document, open, or was it did open? That's like a big thing here. So it's like whenever you actually open a file, this notification happens. This text document did open file. And we can see here that the method here is the text document did open, and its params is the did text open params. And we can look at here, and we see the text open params. It has a text document, it has a text document item. Like, okay, or as an array here. So, or no, that's the wrong one. Well, of course, search just changed what I looked at. All right. So this text document item has a bunch of these information. So if we go back to the did open, which is this did open text params, just search for this. You can see that this is generated here, somewhere down here. It tries to pull in a bunch of comments from the meta model and be able to display them. So if any of these comments are weird or wrong, it's either because the meta model specifies that or they are very TypeScript specific kind of documentation that I've not ever like parsed and tried to make look more .NET-ified. But then same thing here, there's like a text document, and then these have the same properties. If we go back, so if we set these side by side, go to the text document item and see that these look extremely similar. So a lot of that work is kind of a lot of the hard work around getting the information out of the meta model is kind of done for us, or I've already done that kind of work. So what we want to do today, though, is specifically around those notifications and requests. So the thing in this meta model that I did not cover was these two things, these requests and these notifications. And so what we want to be able to do today is generate the server interface and the client interface. So the server knows what it can talk to on the client. We have these hand rolled today. So if we actually take a look at the server file here, we can see that we have an ILSP server, and this has a lot of members on it here. And so very similarly, for example, here's the text document did open. And so this takes a text document did open, and because this is actually, I know some details about this. This is actually a notification because it's only returning an async unit, meaning that this type, so if we actually look for this text document did open in the meta model, it's probably in the notifications. Yes, so the text document did open. You can see here that this is in the notifications section of this JSON or JSON. So this means that the client will tell the server this document opened, but I don't get a response from the server. I don't care what the server does. In contrast to requests, it's always waiting. That's an RPC call. This is always waiting for some type of information back from the server. So with that, all that prefaced, let's get started into what we have to do for this particular task. So to facilitate generating these things, we used Fabulous AST, which is, where did I put it? A project from another Amplifying FSharp member, Edgar. He has been able to take a bunch of, it makes a very nice wrapper around being able to generate FSharp code. So if you come to Fabulous AST, you can see here's the like selling the elevator pitch for using this tool is whenever you want to generate the FSharp code, you want to use the structured versions of stuff. So here is like instead of just generating text and trying to write that out, it's like here is the AST. We should generate code from the AST, and then this will eventually use Phantomus, which will format the code in a particular way, and so we can actually get from AST to good code, like without having to write a lot of our hand descripted text already. But if you look at this, there's a lot going on in here just to generate essentially what is a let binding. Like this is a lot of information. If we kind of break it down here, we can kind of see what's going on here. We have this identifier X. So we have this identifier X here, and there's a whole bunch of fields on this binding node, but we tell it that there's a let and the value, and who knows what all this stuff is. There's a lot of things in here, right? This is like 15 arguments. I don't know. This looks gross. There should be a better way. And this is what Fabulous AST is trying to do, is it's trying to make this a lot less daunting to write. And so for getting the same binding, all this needs to really do is create an anonymous module, create a value, even though the documentation says why. That's if Edgar was here, I'd put him on blast. But the essentially the same idea here is if this was X, this would actually be let X. So a lot less code to deal with because there's a lot of things in here you don't really care about. Specifically, you'll see this range 0. when you look at the AST for FSharp code, the range tells you where the code or where that was found in the code. Since we're generating this stuff, we don't know where it's going to be. It doesn't matter to us. We're letting the formatter dictate this for us. So we don't care about pretty much any place where these should be showing up. We just say, here's the AST, give me a text document. And through the wonderful world of what Phantomus is able to do, this all just works together. So multiple layers here, but this does work out. So what we want to do today is generate a interface. Luckily, we have some code to reference for that. So let's look at the structure of this project real quick. This is a very small project. Luckily, that's kind of its goal is to be just the interface for the language server protocol. So all we have is three folders that we really care about, which is the source folder, which has all the type information and some other small handling of the logic for being able to communicate with the server and client. Tests for that. And the one thing for doing this generation is under this tools folder. It's called the meta model generator. And so if we take a look at the structure of this, we can see that there's a couple of different files in here. The one that we're going to start with here is the program. We'll come into here. I did leave myself a little breadcrumb trail of being able to handle this, but we can see here we have a command line args of parser. So we're looking for types, but we want to be able to add client server. And I've kind of did this in the past because I just wanted to see what was happening. So if we actually go ahead and add the new command to this, so this, we look at the command args, we see that we have this that we want to available to generate the client server. So this allows us to be able to now run some client server code. So we'll handle this client server. So this stuff was already in the pull request, so I didn't write any of this today. So this stuff was already here. I'm going to walk through kind of what I had for this. So basically all this right now is doing is just pulling information out of the request here. We're going to get the meta model and we're going to kind of look at the information that the meta model has before we kind of start getting started with generating this code. And so we have a few things here that we kind of want to look at. So as previously mentioned before, that the meta model has requests and notifications. So the requests are like the sending back and forth, and their notifications are one direction. But they also have something interesting here called a message direction. And so let's actually maybe we should go look at one of these types for a minute. So for instance, this notification here has a bunch of information on it that could be potentially useful. For instance, like here's the method. So this would be like the text document did open. The params, which is what information would we be getting as a parameter. When it was potentially available, but the thing that we're caring about here is the message direction. And message direction we've been able to model is there's an enum here. It's either client to server, so client is sending this to the server. Other way is server to client, or both of these have a respective ability to do this. And so when we're looking at what we want to do this, we want to just group by the message direction. And so in this, for instance, we have these requests that are now grouped by the message direction. So then we can actually specifically look at these are server things, these are client things. So let's go ahead and save that. And to run this, we're going to need to do a .NET build. And I have a force regenerate true flag here. This is the thing that will constantly run the building of this. If we take a look at the language server information here, this will actually generate. We have a target here in the project file that allows us to generate these constantly. The thing that we're missing here now, though, is we do not have a new command for what we just specified. So let's go ahead, do the bare minimum here. Actually, I'll let this run first just so you can kind of see what this will actually end up doing. So this force generate, you can see that it's actually running our meta model generator. And these are a couple of the log file logs that come out from it. So we want to run the other thing, which was client to server, right? That was the parameter that we had, client server, not client to server, but client server. Let's put that in here. I'm also going to just do the bare minimum here. This is something we can clean up later. And I'll just run this again. Ooh, we can see that I did not do something correctly here because I'm missing some piece of information. So let's see. Unrecognized argument. Did this actually build? It does specify that this exists. Let's go take a look at the client server args here. Unrecognized argument client server. Ah, casing will get you. Go ahead and run this again. Okay. So the important part that I wanted to show here is all I wanted to do was just group by here all the server functionality, here's all the client functionality. And so, for instance, we can see here the server. We have a bunch of things here, which is these are all the requests. You can see that these specify kind of like text document implementation, text document declaration. These all are various commands that the LSP supports, right? And they have some type of parameters. And so if we looked for like did open, you can see that this is specified in the notification section here. So we kind of get an idea of all these various different things that this potentially supports. And similarly, the client has a bunch of requests that the server can send and ask for information about, and it also has some notifications. So first thing I really want to do now is now that we kind of have these pieces of information, this was kind of just to help us kind of visualize what these things are able to do and what they support. I think it would be good to just be able to write out a file, get to the point where we can just write out a file and add it to our language server protocol file here. So I'm going to kind of cheat here and look at the generate type because we're going to be following something similar to what we're doing with the generate type. And what matters at the very is at mostly at the very bottom here, which is actually writing out this file. So let's create a function called let generate clients server. And we can see that Copilot's helping out a little bit. So let's handle that. Don't need this though, Copilot. Thank you very much. So what we really want to do is be able to write something. We just want to be able to write to some file. So we need to be able to do some type of thing that we're missing here, some type of oak. So oak is a cute name for a very strong tree. So Phantomus added this ability for really, really good ways of handling the AST in a slightly nuanced way. Florian can talk about it a little bit better, but it is a really nice way of handling the code from another AST perspective. You have anything you'd like to add, Florian?
Definitely. So you're sugarcoating it a little bit, but the AST that the FSharp parser makes is just kind of funky from time to time, and it's also rather optimized for what it eventually needs to do in the type checking phase, while it's less ideal to sort of revert back to source code. And there were so many edge cases over the years that we had to deal with because the AST sort of shuffles the information in a less logical tree from time to time. And at a certain point, it was a lot more convenient to have our own tree. So that's why we named it Oak. The great benefit of Oak is that it can also carry something we call trivia, which are code comments and potential sort of conditional defines. Now these are part of the AST, but the FSharp compiler AST just has them as like a big list. Like if you have a code comment, it will let you know that, hey, on this line there was a code comment. But for Phantoms, we need to puzzle where exactly are we going to write that comment out when we format. And that's what Oak also solves. Maybe just another link to Oak and what Fabulous DSL does. Fabulous AST will be a nice wrapper over Oak because we made a very conscious decision that Oak is more or less an internal thing for Phantomus, and we don't really want to, guarantee users of Phantomus core that Oak is going to be stable in between versions. And, to have that freedom, we also don't have a very good public API, and that's again very deliberately because that would, the maintenance of that would be hell. That's why we in the example you saw in the documentation, there are a lot of things where if you don't need the information, you need to pass a none. We are very specifically just not doing that. We're mapping what we get from the AST, from the FSharp parser. We're mapping that to our needs, and that's the end of that. So that's why another additional layer in Fabulous AST just makes it convenient for people who want to generate source code out of thin air to really use that and to really use the Oak model. So that's more or less the story there.
Awesome. Let's see. One of the things that we need to now generate is that type or that file, but we want to potentially have another file. We don't want to overwrite our types. So let's do client server. Let's call this meta model. Client server outputs for the moment. We'll clean up all the cute stuff later. And then I do not remember my MS build syntax. Is the ability, can I do a semicolon or is it a colon or comma? Don't remember if this is something like this. But we'll see if this actually generates a file for now. The only other thing we need to do is actually call it though, right? So we want to do generate types, generate client server, meta model, output file, run synchronously. Oh, meta model, not path. Thank you. Go ahead and save that. Let's go ahead and run this and just see if we get ourselves a new file. Is not defined. Oh. It's very useful saving your files. You can see that we generated a client server CG file and we see that we get an empty file. Hooray, now we can start partying on this thing for a little bit. So the first thing we probably want to do is just be able to define like the name of whatever we're kind of generating. And so we may have to do a couple open statements here eventually too. Guarantee that we will, but for now, let's take a look at kind of how I generated the interfaces on here. And so what ends up happening for a lot of these types, we also generate an interface as well as a concrete type for some of these things because there's a lot of like actual what's the hierarchy going on with their type definitions. And so we actually do want to generate a lot of these interfaces. So if we actually take a look at where I did some interfaces, create interface structures. Let's see, where am I getting into? Okay, so here is an example of creating an interface structure, is what I called it here. And so the thing that matters here for us is this type definition. And I think abstract slot. This is an interesting name for an abstract member, but this is essentially the abstract member that we want to generate here. So I'm actually going to split this code up and come down here. Usually if I'm doing this is a problem, right? This is too many bad things happening in a code base, but we're also just trying to get things to work. So let's create a type definition. Let's call it the ILSP server. Gonna give it this. Does this need to be in a module? Probably. So let's make this an anonymous module. Anonymous module. And so this thing, because we can't actually have empty computation expression stuff, or we need to just be able to run this. So let's see what this gives us. This is probably not going to do anything useful, but it will be cute to see what we get. Ta-da, we got an interface. There's nothing really useful here though, right? This wouldn't even compile, but I'm not getting any type checking because this is not added to my project. Um, so let's look at what I did here, which is this abstract slot. Let's go ahead and try to figure out how to make just a member for this. So this abstract slot, we'll just say member one, and we potentially need to give it some other information. That's the identifier, return type. Do we actually need to give it anything else? Can I just say member one, or do I have to actually give it a type? I probably need to give it a type. Is there more than this abstract slot? Yes, there's a lot of overloads here. This is going to be very fun. So what we want to potentially do is give it an information and some type of parameter, some type of widget builder. So it looks like we can also just give it a return type as a string and it'll figure out for us. Let's go ahead and run this, see what this does. Wow, we have the best interface ever now. We have an ISP, we have an abstract member, send notification. That does nothing. Yay! So this is the general start of what we're going to be wanting to do here, right? So now that we at least have something to start, this is at least getting us to the point where we can start doing something here. First thing we really want to do is generate the types or for like the notifications and the requests. And so as we kind of looked at before, we want to be able to potentially deal with those types in which direction they are. So we need to actually do a group by on some of these information. So let's go ahead and um, I did I probably deleted the stuff that I could have copied and pasted over, didn't I? Nope, I did not delete it. Good for me. So let's go ahead and just handle these. These will get us the requests. Change the names of these. All right, let's get ourselves a set of server information. And so we have requests. We want to client to server. It's other way, Copilot, but nice try. What did I call that? Message direction. And server to client. No, maybe I am wrong. Maybe it is server, client to server. I am good. I'm smart. All right, so that will give us a list here, but we actually just want to flatten this list. So if we actually don't get anything, let's just make a optional value of an empty array. And so this gives us a list of an empty array. So let's just do a yield bang on here, which should give us a flat list now. Sweet. So now we just have a list of server requests. I guess I don't necessarily need to use a list here, but that was kind of the start. So we could, the one thing that I kind of want to potentially do is merge these requests with notifications, but we'll see potentially why I want to do that soon. And then we can do this, same thing. I'm also going to potentially need this both directions. Yes, that is why I started with this. So we end up having both client server, and if we don't find something for either of these, we just flatten this list. So now we just have a list of requests. So let's start with the notifications because there's a lot less of them, but let's just start looping into these. So like let's do a for loop here. And let's do the most basic thing and just spit out the method names for now. And just see what we get here. Let that run. We're probably going to get something kind of gross, I would imagine. And we can see here that that's kind of true. We're getting these like workspace slash things, and this I don't think is necessarily valid FSharp code. You can't just have a slash in your identifier like this. So we can kind of go about this two ways, which is normalizing these to kind of what we do today. So if we actually look at our server, we kind of normalize these into like the Pascal case and just kind of eliminate that, which I think is fine because I think we probably want to try to keep that as best as we can for now. The other way is to actually, end up using the backtick thing, right? So I can put anything here. Right. But this is, well, it's kind of cutesy. I think it's probably not worth doing. There's a lot of times this just doesn't play well with either like debuggers or tooling. Sometimes it just gets really nasty. So I'm gonna avoid using the backticks thing for this, and I'm gonna want to try to normalize these. So let's see what we need to do here. So we have two pieces. We have this text document slash. So let's go ahead and let's call this normalize method. And we'll take this string here. We'll say something like, let's do a split on slash. I don't just want this array now. So I have these parts. And what we want to do, I'll also specify something else here is string split options. I'll remove any empty entries. And can I add more things here? Let's also trim any entries. So this should allow us to just, if there's any like weird spacing in here, just get rid of all that kind of stuff. Because what we also want to do is filter, like I don't know what we're going to do with this $sign. I don't know if we actually need this. This will be something we'll kind of think about later. but I think these are specifically like some different types of requests that we may not necessarily need to handle. This might be something that is handled more on the JSON RPC side of things for us, because the protocol is actually JSON RPC. But let's kind of do that. Yeah, 2 Pascal case. Yeah, that's a great overload. Where did you get that, Copilot?
Humanizer. Humanizer, Jimmy.
Is that a thing?
That is a thing. That's like a NuGet package that deals with crap
Ah,
like that.
okay. Well, I'm not going to take a NuGet package for just one particular thing, right? Um, let's do the most bare minimum thing here. This is going to be terrible, but I don't care. Or is it substring? I want to start. Do I need to
You should do
string
the
this?
spreading thing, right? Like one dot dot. Is that how the
Is
cool
that
kids
it?
would do it?
I
Yeah,
don't.
well, I mean, not with the substring, but with like square
Oh,
brackets.
yes, that is the new syntax. You are right. Oh, boy. Does that string does not match because this is a char now? Is that the problem? Okay, and then I'm going to also just do to upper this. And then we also want to get rid of that. Um, Most bare minimum normalization. So let's see what happens when we do this now. Oh, I didn't use it. Nothing's going to happen if you don't use it. Put this right out, and we got some interesting things. This looks a little bit better. This looks like something that we can kind of work with. So let's actually add this to our file here, to our project. I'm going to add this below the type generation stuff. So do client server, spell it right, save. So we still get something here, which is I probably need to actually have a namespace or a module, but this is at least looking kind of decent. So let's take a look at what I did for the generate types namespacing. Scroll down here. So I end up creating a new namespace. So let's go ahead and create a new namespace instead of an anonymous module for the moment. Let's call this, it's just going to be this namespace. Where did we put these? What was the original namespace for this? This is just here. Okay. And we're probably going to need this open statement eventually, but we won't do that for the second. Go ahead and force regenerate. So we got a namespace, and now we have our very first interface that's at least a little sane. Obviously, the problem here now is we need to handle the parameters and the return types. This is where it's going to get probably a little bit messy because we actually have to we probably have to do a little bit of like recursive descent of things, potentially. We'll see. We'll see how deep this has to actually go. Let's see. Is we have any questions anywhere on any chats? I guess I don't see any. Nope. All right. So the next thing we really want to do is be able to actually specify a sane return type and potentially and the sane parameters. So let's also take a look at the notification here. Let's go to type definition. The things that we care about is the params. And we do have some documentation that we'll eventually end up using too. And since this is a notification, this is actually benefits us here because we know the return type. It's going to be an async unit. Since this is an async request, there's no return type in a notification, it's a unit. So this is actually going to be really easy to do. Just gonna make this async unit. Ta-da! Now that was cute, but now how do we handle parameters? We actually need to deal with the params that come through here. Let's take a look at that. So let's take a look at this abstract slot again. Let's see what overloads do we have available to us. We have this identifier and the return type, but we're using like a string. So we do have the identifier, the parameters of a string option with a widget builder. So I'm guessing this gives us a name available to make a name for it. And then this is the simple option. Let's see how far we get with just doing the simple option before we get a little bit deeper. And so we have this parameters, a return type of string. And so this is going to be a name and a type. So let's say let method name, let's just go with let return type be the same for everything, just so we know. So we keep these kind of not too mixed. And then let's go for a let parameter name. And I should have kept up the overloads. So let's see, that is a list. So this is going to be a some name, and let's just make this a string. Move this return type. Let's move this. Let's see what this gets us. Let's see how far along this gets us here. Cool. So this does allow us to specify the parameter and the type here. So then what we can do is take this instead, given that we have the structure. That's for p in parameters, param safe. So one thing I'll touch on, this param safe is a member that I made for this params because technically this is a type array option, so meaning that they may not actually have any parameters. So we probably are going to have to handle this case where it's an empty list. This may be a unit type that we have to handle. So let's see what we get here and do a yield of a name as Pascal case. Do I have what is this information here? Aha. So this is going to be where it's a little bit interesting because we do have a bunch of different various types here we may have to handle. But we may be able to get away with handling this easily. We'll see how far we get with this because this is where we're gonna potentially start getting into this recursive descent thing, where we start looking at these types and handling these. So let's do the bare minimum here, which is let's match on this type for the moment. Let's go with let's go with reference type. How about that? I think it's r dot name, and then we have the r dot kind, which is going to be a string as well. And then let's do nothing for anyone else for the moment. Oh, I need to just make this a case. All right, let's go ahead and run this and see what we get from here. We're probably going to actually get bad code. We can see that, yeah, this kind was wrong. This name is this. So maybe I don't need a name. Maybe this reference type, does this parameter have a name? It does not because it is its own thing. This reference type has a kind and a name. And so the kind is referring to itself. And then the name is just the actual parameters that we care about. So we don't actually have any names for this. So this is actually going to be none. And then this is going to be name. So let's go ahead and run this and see what we get here. This might be a little bit more sane for the moment. All right, cool. So we know that these things do exist. We've generated these previously. So let's actually just add that open statement to this here. It's like open, thank you, but I want dot types. Let's go ahead and run this. Now let's see how this potentially interacts. Typo when you misspell types. Amazing. Amazing. Let's regenerate that again. And we got something kind of sane, it looks like. The only one here is this exit. I'm guessing this actually needs to be a function. This looks like we're not handling. It's interesting that we're handling all these reference types here. And in this case, that just works. Like we don't have to actually think too hard about these types. Mainly because if we look here that there's this type definition, there's a lot of different types that these could be. And so, for instance, like a base type is like a string or an int. Reference type is these kinds of just like we've created a specific record. And then we have other things here, right? Like arrays, maps, and types, or types, tuples, so on and so forth. And I didn't have to handle any of these, which is kind of interesting. Even though that this type has all these potential cases, notifications really only seem to use that. Okay. So that we know though that the exit is probably needing to be a function in itself. I actually don't think I can use this param safe. I actually want to match on that params and see if there is a none case. And if there is, we will specify this. Thank you correctly. And then this will be the P's. And then this can be that. So let's go ahead and run this for now. And that looks a little bit more sane for the moment. That looks pretty good as a first pass for being able to generate notifications. I'm kind of happy with this. I think this is kind of cute. But now we need to do potentially methods, which have a return, also have another like interesting return type. That's probably where it's going to get a little bit more messy because I bet you there's a lot more return types in there. So let's do something similar. Let's actually take this normalized method because we know we're going to need this. Let's move this out to here. So this should say function, not method. Let's normalize. So let's see how far this gets. The return type, though, we also are going to have to look at the request here. If we actually take a look, there is a the one difference between these two things really is there's this result type. And we're going to have to do something similar here where we specify matching on here. If there is actually a type, we always know there's going to be something. I don't know why it wants to match here. Let's just do result. And if it's not that, let's just make this a, I guess we'll find task units and see. This will just help us stay kind of same with compilation. Nice that Copilot was able to write quite a bit of this. And yeah, we're kind of running into some interesting problems here. There's no inline completion params, and there's no this. So this I can tell you, I think I know what these are off the top of my head. There is a set of proposed APIs and endpoints that exist within the LSP spec, and we actually do need to filter those out. So I'm going to go ahead and filter those out here. I think this would be a good place to do it. Or can I do it here? And then I have something, it's like check proposed. I want to say I have a helper for this already. Proposed, check proposed. Yep. Okay. And so this should eliminate any of these that don't actually exist. Any of these endpoints that shouldn't actually exist on the current spec. So that helps clear those up. Cool, but we see that we do have a lot of like async units. So clearly there's some return types that don't necessarily make sense. Let's pick one and see like which don't necessarily make sense here. The text document, yeah, let's go to implementation. Let's check this out. Let's go to the meta model. We know this is supposed to be like text document slash implementation. Look at that. Wow, it's the first one. We can see that the result here is an or type. So we actually do have to potentially have like a slight recursive thing here now, because it could be a or of one of these two things that we know about. It's interesting that it's actually 3 items, and we'll have to handle some interesting cases. So typically for something like this, we have you either get back a definition, an array of those definition links, or null. And so we're going to have to handle all these, which will be very fun. And so let's actually take a look at these different types again, just to kind of see how they're referenced or how I modeled them in FSharp. So you can kind of see how they line up here. And so when you look at the result here, this has a kind, and this kind is going to specify what kind of DU this is part of. This or, so we can see that there's an or type. That's how this is going to relate. Take a look at the items. That's the information in here, which is this items here, which is another type array. So this refers back to this type. And then similarly, here's the kind, references the reference. Array, also a array type here, which has the array elements. And then it also has the kind of base, which is the thing I mentioned before, which is we take a look at the base types. Base types have various normal types that we'd have here, which is like URIs, integers, strings, booleans, and specifically in our case here, null. So this is where we get to have the real fun of the project, is handling this, because we're actually going to need some type of recursion to handle this kind of problem here. So let's say we have a return type here. Let's call this actually a result. So this is actually a type. All right, so let's call this a type here. So we know if we have a reference type, this is something we can handle almost immediately. If we do have a base type, we potentially could return this. The problem with necessarily doing all these is these might not be, we can't have an async of, like, we can't have multiple. We need to be able to join these together. What do I mean by that? So let's just handle this case here, right? Let's go a little bit further before I dive into that. So if we actually have this base type, we let this go ahead and specify a bunch of these. This is like decimal. Let's just see what we do here. Go ahead and regenerate this. This is going to potentially also not work because we know that we're dealing with an OR type for that particular case. So let's handle the OR type for the moment. So now that we know we have this OR type, go back and take a look at its definition. So we have a list of items here. So we kind of actually need to collect a lot of these types because it could be one of multiple. So we're going to want to say like let types equals and do a recursion. So we want to actually be able to recurse over these. The thing here is, yeah, Copilot's going to try to just like use anonymous unions. This doesn't exist in FSharp. This is not something that's possible. Let's just see what they do when I run this. This is going to generate some bad code, but it's kind of interesting for kind of demonstration purposes. There's a lot of async nesting here, but that's because we just stuck async everywhere. But the interesting, important part here is, right, is it's trying to create like an anonymous union. This doesn't exist in an FSharp. If you've ever played with Fable, you're probably familiar with like erased union types. And so you may end up creating like a couple of different cases. We do something similar where we have a set of cases that are potentially erased. Let me go take a look at that real quick, which is in the types here. So you'll see this a few times if you ever do play with this code. We do have something called an erased union. This is kind of knowing about this is potentially one of these 3 items or 4 items, or 2 items in this case. And this allows us to just specify that this is how we kind of handle anonymous types here. So what we need to actually do is create a union of these things. So let's back up to our function here that we're trying to generate these for. We don't want to do this. I'm actually going to go ahead and remove the async portions of these things for now because I know this is going to get into some like fun wrapping of stuff here. Let's see if I can just specify unit. Cool. Boo.
Hello, Jimmy. I think I created some widgets for the types as well. So I think there's a unit widget and there is also a string widget and all of them.
Okay, cool. That'll be something that we could potentially work on after this. This is kind of, I'm just trying to get through like some of the general flow of these things.
Cool. Yeah, sounds good.
Even though these are strings and stuff like that, it would be nice. It will be nice to make these a little bit more defined. But like for instance, like a reference type, I have to figure out I have to generate like a widget for that. But let's see. The return type, I've already went through that, so I don't need to run return types again. I just get the 0 here. Dot. Oh, I don't know why. I just want the type dot 0 here. We may end up regretting doing a type 0 here. So instead of this kind of like anonymous union, we need to be able to create these cases. I do have some code around creating those cases. So let's actually see what I did before, because I don't remember off the top of my head. Let's see if I can create a U. There's a bunch of case. See if we do U. Aha. So I do have a helper here called create union. We do probably want to elevate these to a potential type here, which is this is actually, you're going to see various overloads for the same stuff constantly in here because there's the LSP version of a type, and then there's the FSharp idea of a type, and then there's the Phantomus idea of a type, and then there's a Fabulous idea of a type. You're going to see this all over the place. Um, it's kind of fun. Um, but for brevity, maybe I will just create. Can I create this with a string, or do I have to, is there a way to elevate this relatively easy to a actual type? So if I actually called create erased union with these types, right? This is going to actually generate a widget here, which I don't necessarily want to do at the moment. But this app prefix allows us to create that. So let's see if we can just do a simpler version of that for the moment before we kind of get elevating into widgets. So we know the type length, so it's going to be oh yeah, this is the problem, is because we actually want to let this handle the various points because we don't know what this length is actually going to be. Or when we do this for loop, we're going to be like adding commas, which I guess we can do for the moment. Let's do it. It's going to be gross. I don't like this, but let's just try to get something to see if this is actually kind of going down the right path, right? Um, let um, and then this is going to be a loop of these. It's going to be actually I'm just joining on this, right? So it's going to be types, go to string dot join. I don't have a helper for this, so we're gonna have to use a base type. And then types. And then let's do a du type and inner. See, we're getting into code generation where I'm actually writing the code. This is gross. This is stuff we don't want to do. We will clean this up. But let's see if this kind of gets us to the place that we're looking for. And it kind of does. We can see now that we're actually using these erased unions instead of other things here, but you can see I'm still not supporting everything. There's a bunch of async units here, which are not good. And then necessarily the one big problem here is this unit, which is actually handling null. So we'll go back to that in a minute, but we do kind of want to look at potentially, I think arrays might be the next one we kind of want to look at here. Again, I don't really want the async. Thank you, Copilot. Just want the return type. Oh yeah, we also need to specify, this is where it gets kind of silly, right? Again, don't do this at home, kids. Why is it complaining? Oh, I need to not have the sector type here. Similarly here, let's go ahead and force generate this. All right, this is starting to look a little bit better. We're actually getting the erased unions here. And so these could be a union of inline value array. So let's take a look at this inline text document inline value. Let's go look for this very quick in the meta model, just to kind of verify what we've been doing is making sense. So the inline value here is we end up having this, which is, yep, the array type that we wanted to specify. Let me bring this over here for the moment. It's text document inline value. So we have this 2 items, the array with a reference type to inline value, and then the base value of null. Well, that's going to be a problem. Unit, null is not unit. We know what null is. It's option, right? So how am I going to handle that? Because we don't want to specify this here. This is going to be this will be a very fun refactoring exercise. I've kind of done this before with the generate types because this is handles options, but we do want to kind of look at what I'm doing with regards to is the type nullable. So let's go ahead and take a look at potentially if these things are optional and see if I can copy and paste any code out of this for the moment to kind of get through this area. And so in this potential case here, we're looking through the OR type. And in the OR type, because a lot of times these OR types, this is where the case that we matter a lot here is this OR type will potentially have nulls. This is where we want to handle this. So it looks like I kind of handle this by just having is optional here and removing it from the set of types. And then I handle this somewhere later, specifying this that kind of needs to get wrapped in an option type. So let's do kind of the same thing here. I think that makes sense to do. It's gonna be, again, pretty gross, but I'm just trying to get through the like let's get the general ideas right, and then we can come back and refactor and make this a lot nicer. And so of items, we can now know if something's optional. Did I mess up? But yeah, this is also need to go another indent. Okay, so now we have these items. Let's actually use these items here. This will actually filter out the optional, and then before we end here, we can look at and say if something is optional, we want to potentially wrap this. So we have this return type, it's optional, wrap it in option, otherwise that. Again, I'm handwriting these code pieces. It's kind of gross. Don't want to do that. We will clean that up. But this is looking a little bit better. Now, if we look at this whole thing here, we know around here is when we stop. This is where we started getting methods or requests, I should say, and then this is where we started getting notifications. And so now we can take a look at this and say, does this kind of make sense? We have a text document implementation. The three values that it potentially could have is definition, an array of definition link, or it's null. I do got to wrap this all in async again, but that's a separate thing to potentially do. I think those kind of make sense. Let's also look at semantic tokens range params. Let's take a look.
Quick question out of
Yep.
curiosity. Is Fabulous AST, does it allow a way to like insert code comments?
Yes, yes. I don't, well, it is, if it's for doc comments, for code comments, I don't think there's an API. I know you, since you can just do an escape hatch anywhere, you can eventually write those. I think I do have an example of doing that somewhere else that's not in this project. I have to go fish it out. But that's something we can look at too.
Because you could, in theory, I guess, sort your members a little bit or make a group with all the text document stuff, which is probably your requests, and then shove in a code comment or something.
Yeah, we could shove a code comment there. I'm just saying that I don't think there's necessarily a code comment specific thing for like there you can add like doc comments, but there's no like code comment thing in Fabulous AST. Feature request, feature
Gotcha.
request.
Yeah, I can make that happen.
Because I think there is like you do have an escape hatch, so I'm sure you can do it in some way. Like I said, I think I do have a way of handling, because there's like what if we go into the real depths of stuff, right? There's like there's the syntax oak, right? And then what do we call comments essentially? They're like trivia. There's like a trivia node. And then yeah, there's like a syntax comment. Does this just, do I have to specify like / probably? There's a line comment on single line. I'm guessing that'll be fine. And this thing does have a range. This thing needs, that's just that. So I don't think it needed that. What's the typical thing here? It's like range.0 or something. I'm sure I
Mm.
gotta import something specific. Yeah, something like that. And so this should be able to create a comment.
Well, this is a comment that you'll need, well, to shove it into some sort of node, and I was just curious if that's a thing or not.
Yeah, I don't. So like we do have these. So let's say we just have this comment. I guess I want to do this before I do notifications, right? It's like I want some comment here. Let's see, what do I do to shove this in as like an escape hatch?
Yeah, I think that will be possible to add a new widget like code comment that will basically, behind the scenes do, what the Fantoma needs to generate and, allow us to put it everywhere like we do with the open type. You can put that everywhere.
Mm.
Yeah, we look
It's
into
like
that.
all the Oak nodes sort of have like an interface node which has a
Mm-hmm.
method add before, add after, and that's like
Nice,
the way you would shove the trivia in there.
nice. Yeah, good idea. Thank you.
So it's not really in any other constructors. It's once you have the node. But I guess from
I
like
see.
the widget side, that probably is possible.
Yeah, definitely. As an extension method, right? Like, right, or something like that, or repeating an, in a parent widget, something like that. But yeah, I will investigate a little bit that.
Yeah, because we have this member definition abstract slot node, right? And what does this give us? This has like XML nodes and attributes. So this is
It's never going to be in the constructor. It's really once you have
yeah,
the like node.
yeah, right. But I'm forced to be a widget builder right now, right? So is there something on here I can get at
In theory, what you could do is compile it
file?
down to a Fantomas Oak node and then do the add before and then add after. I think as Florian said, there is some interface there that you can use, but it won't be really, like nice. You will need to cast it and all of that. So yeah, I think just need to spend a little bit of time trying to make that happen.
So once I compile it, do I
But
need to like actually use the make oak or something with this?
yeah, but not that compile. It will be it's in I think let me have a look. Well, I think it's in the
Okay.
generator. Where's this?
Yeah, so we have this. Okay, now we have this, so then I can do like
Okay,
add
so
pieces
it's
like I had before, comment, and now I have this widget, and then what there's escape hatch, right? And I can just pass this in. Okay, let's see. Let's see what that does. Yeah, this is where it's like nice for, there's at least the escape hatch, so there's an option for doing this, but it is kind of could be
yeah,
cleaner, I guess.
yeah. I will improve that.
Oh, I need to reopen that file because oh, I put it before every single one of these. Yes, because
Nice.
I don't want to do it for every single one of these. I just want it to be like its own standalone node.
Well, you'll probably need to be clever and add it to one of the abstract members.
Yeah, the first one or something.
Yeah, or just, you know,
Yeah, because I'm doing
do
that
like
for
a
every single one of these. Yeah,
basically like if your method name is something in particular or whatnot.
so let's just say, let's be nasty, right? let mutable. I don't. Yeah, something like that, right? And then we just say like these are notifications. Notification comment, and then guess we probably want to do one for requests too, right? Then what I do down here. So turn this into a widget builder and then do this, right? And before I get too far, I know I misspelled this. And then this is going to be the requests. Okay. See how that looks. Did I not save? Oh no, I just used the wrong thing. Okay. There we go. So at least we've had these specified now to what these are. I guess I could also like sort them and whatnot, but do that later. But yeah, the main point now is we're able to handle the option and the folding range and the array, which I guess is not too bad, and this is compiling. So I'm guessing we don't actually have to handle any more of these base types for the moment, which seems kind of, or any more of these other types for the moment, which is interesting. But this is in the realm of but I think that's at least a good place to commit for sure. Like I think we've gotten through like a big bunch of hurdles here. And I think this is a good place to at least commit these things. Let's go ahead and say generating LSP server interface. And not com. All right. So it's at least a good start for this particular thing. So we are, I mean, that's a pretty good work of progress, I think. We are at an hour and a half now on this topic, but I think this is a good like start to see what's going on here. Adding the client would be pretty straightforward as well as we just be adding essentially the same code for the client, and then we probably refactor based on how similar those things are. We are missing this being wrapped in async as well. So let's just do that. Well, we could handle that. And then yeah, this is still kind of using strings because it was like, let's get this dirty and kind of see like what this can kind of look like. What we'd probably want to do is when you look at the generated types, we do actually have some recursive methods around these similar concepts. So like I stole some of this code here, but we could probably do a little bit more structured approach here and actually use the correct widget builders, and instead of just kind of building these things up by our strings, like we could actually create these as real more strongly typed versions of themselves. Well, with that, does anyone have any more questions? I guess there is one question in the chat. Oh yeah, that's from Edgar. Is Phantomus or Fabulous AST holding together so far? The answer is yes. But given that I already had these things parsed, and there was a little bit of like knowledge of headspace around these things, like going from, we didn't have interface at all to this actually looks pretty similar to what we probably have in the server right now. Let's take a look. Just take a look at the text document symbol. Actually is very similar here. Like I said, there is a little bit of a different dance here, which is an async LSP result, which helps us deal with some things on the back end of dealing with the JSON RPC spec stuff. But this does look pretty similar. We have a anonymous union symbol information array or a document symbol array, and it's wrapped in an option. Slightly different syntax, but same kind of core ideas. The other thing here is also getting the doc comments correctly aligned. All right. Well, I think this is a good stopping point for us today. Just as a reminder, you can come to employing FSharp.io, go to their sessions link, and check out our previous sessions. You'll be able to see this video and other ones that we've done. We've also done a video on Fabulous AST before, so if you want to also kind of see like the bare bones getting started from that, watch that video. Any last comments from anybody else?
I just wanted to say, to be honest, that this is the perfect example of three open source projects, working together, like Ionide, like Fantomas, and Fabulous AST. We all understood that there was a problem that we tried to solve, and rather than do our own things and reinvent the wheel, we came together and we implemented something that will benefit the three of us. So yeah, that's basically, I think, what we should try and to strive as a group of individuals or community, if you're going to call it. Just try to collaborate and try to do something like it's going to apply for everyone, at least for most of the people, I guess.
Yeah, I definitely agree. Like this is like standing on the shoulders of giants kind of stuff for sure. Like Phantomus being as like great of a tool as it is, and then being able to utilize its facilities for formatting code to generate code from the AST, and then using Fabulous as a nice wrapper around having a great experience around generating code. And then this lines up to being, part of the LSP, which we all use to edit. If you use VS Code or Vim, if you use Writer or Visual Studio, you use something else. But like they're all helping each other out in various ways and making our lives and maintenance easier for our products. All right. Well, thank you very much, everyone. I'm
Thank you,
going
Jimmy.
to have a good rest of your day.
Thanks.